Okay, sequences in series lesson number 1. Okay, so in math there is these things in math called patterns, and like if you start to find, a nice way to establish patterns, we find that there's these things called sequences, and then from there we can develop this thing called the series. Okay, so we start with a sequence, and this is no different than like when you were in elementary school and you're just learning patterns. Like, remember when you're learning how to multiply, like, how would you learn to multiply by twos? You would skip count by twos. You'd go 2, 4, 6, 8, 10, and you just have a list of numbers like that. That's a sequence, and that's all it is to start off with, a sequence. There's two types of sequences we're going to be working with. One's called the arithmetic, so you are going to be adding, like 2, 4, 6, 8, you're always adding 2. And then the other one's geometric, and that one's where you're multiplying. So it'd be like 2, 4, 8, 16, 32, 64, like that. So sometimes you add, that's a arithmetic sequence, and sometimes you multiply, that's a geometric sequence. And we won't get into series quite yet. Sound okay? All right. So I really not a fan of these investigations, so I tend to skip them. Okay, so we are going into, if you want to do those investigations on your own time, that is completely up to you. Okay, so it looks like we're going to start from page 3. Class example number 1. All right, so in each of the following, complete the table using the informations from the tables. Okay, so for B, we want to complete the statement explaining how to find the next term in the sequence from the previous term using only addition or multiplication, and then we're going to state the next two terms of the sequence. Okay, so in table A, it goes 3 and then 6. So you have two options here. You don't know what the next one is. Let's just keep this one arithmetic just by adding. So let's do table A by adding, and so just put in arithmetic there, and I'll spell that out for you. Arithmetic. So we're just going to add to get the next term. So how do you go from 3 to 6? You've added 3, so finish off the table. 9, 12, and 15. Okay, so we have two spots in the table. Just like when you're doing relations in math 10, you kind of had like an x and a y, two variables. It's similar to that. What you have here is n, which is the number of the sequence, and then you have tn, which is the value of the sequence number. Okay, so let me jot that down up above for you. Okay, so sequences look like this. You have your first term, T1. Then you have a comma. You have your second term, term 2. And then you have your third term, T3, and so on, dot, dot, dot. And in general, what you have there is Tn. All right. So for the first term, T1 in our sequence, T1 is 3 because n is 1. And term 2 is 6 because n is 2. And that's the relationship there. And we denote that by Tn. So this is a big thing. This is the notation for sequences. This is the notation, Tn, where n is the number of the term, whether it's the 5th term, the 7th term, the millionth term, right? and the Tn is the value of that term. Okay? Okay, the next term can be calculated by adding 3 to the previous term. So T6 would be 18 and T7 would be 21. Okay, so I think these tables are coming from the investigations. So we would have had to do the investigation. So you just got to flip back a page. So for table B, it starts off 1, 3, and it's also arithmetic. Okay, so A and B are both arithmetic. So how do we get the next term from 3? It'll be 5 and then 9. Okay, and it's all really basic. You're like, okay, Mr. Lineberger, this is too easy. There's got to be a catch. So like, what if you wanted like the 1000th term, right? Like it's easy when it's like the first 5 or 6 terms. You can just do it by hand and it's nice. Like what if you want the 1000th term? You're going to do it 1,000 times? You're going to write out that list? No. You could get a computer to do it for you really quickly. If you wrote a quick program, that would be super fast. But there's a formula that we can derive, and that'll give us any term if we know the value of n. Does that make sense? Just come up with a formula and it'll work. If you want like some random number, okay. Okay, so the next term can be calculated by adding 2 to the previous term, and T6 is 11 and T7 is 13. All right, the next two are going to be geometric. Okay, so table C and table D will be geometric. So I'll give you the first couple, and then you're going to have to get the next ones. Okay, so if it starts off 1 and then 2, and it's geometric, which means we're multiplying. Okay, remember arithmetic. You could put a plus by arithmetic to help you, and you can put a dot by geometric to help you. So dot is multiply and plus, or the cross is addition, right? Okay, so if we went 1 and then 2, how do we get from 1 to 2? We must have multiplied by, careful, must have multiplied by, so the next one is 4 and then 8 and then, good. And that just goes on forever, infinitely. You could do that for as long as you ever wanted to. So the next term can be calculated by multiplying the previous term by 2. So T8 would be 128, and T9 would be 256. And this geometric sequence in specifically is a very powerful one. These are the powers of 2, and they help us a lot in computer sciences. This is like how binary works, and bits and stuff like this. So very, very critical sequence for us. Let's go to table D. Table D starts off with 32 and then goes to 16. So table C, the sequence is increasing, and table D, the sequence is decreasing. So what have we multiplied by? Remember, we don't divide. What have we multiplied by to go from 32 to 16? It has to be a fraction, right? So some of you are saying the decimal, but the fraction is 1/2. Good. So from 32 to 16, you must have multiplied by 1/2. So basically you're dividing by 2, right? But it's just multiplying by 1/2. So the next term will be 8 and then 4 and then 2. Good. So the next term can be calculated by multiplying, not dividing, multiplying the previous term by 1/2. How's that feel? You guys okay? Not too bad off the beginning, hey? Not too bad. Okay, and we'll just do one more. Let's do table F. Table F is also going to be arithmetic, and I'll start it off for you. 8, 4, 0. I'll start it off for you. So what are the next two terms? Are we increasing or decreasing? Decreasing. And are we adding or are we multiplying? We're adding. What are we adding to decrease? We have to be adding. Good. You're adding -4 to the previous term. Okay, so let's finish off the chart. It'll be -4 and then -8. T6 would be negative, and T7 would be negative. Good. Okay. Remember, we're not subtracting and dividing. We're only adding and multiplying. Types of sequences, we just talked about this. You have arithmetic sequences and you have geometric sequences in this course. So this is your focus. We also have infinite sequences. That's going to be part of your studies. And then this other sequences is stuff that sort of just doesn't fall into the category of either arithmetic or geometric. So for example, if any of you are aware of the Fibonacci sequence, then this would be a type of other, is a Fibonacci sequence. You guys know the Fibonacci sequence? You know it? Yeah. You just take the previous, you start at 1, well you start at 0, you start and then go to 1, and 0 is optional. And then you add the previous two terms to get the next, so then 0 plus 1 is 1, and then to get the next one, 1 plus 1 is 2, and then the next 1 plus 2 is 3, and then 2 plus 3 is 5, and 3 and 5 make 8, and then you just keep going, like 13, 21, 34, 55, and so on. So that's a type of other sequence, and we're not going to be doing any of those, so you don't have to worry about any of that. Okay, so your focus is arithmetic, geometric, and then we'll also do these infinite ones. Do you guys know what I mean by infinite? Just like goes on forever. Like if you think about counting numbers, 1, 2, 3, 4, could you just go on forever? And that's all that is. We already classified, so we'll move on. Here's the definitions for finite and infinite. I don't know why it's pronounced like that, but I always say finite. I don't say finite. I say finite. So it's got a specific number of terms, and you can see this is typically how it's done. Like they give you the first few to give you the pattern, and then ... and then they give you the final term, and then sometimes you have to figure out like how many terms there are. And then there's the infinite sequence, and that's denoted by the ... at the end. Clear on that? Yeah, and then when we talk about series is when you add stuff up. So series is when you add the terms. And we come to some really, really bizarre conclusions, because for some sequences, for some infinite sequences that go on forever, if you start to add up the terms, they actually will just add up to a finite number, which is really weird. You're adding an infinite amount of things, but it will only be a certain number. It'll be a finite number, which is very bizarre and pretty cool. So that's where we're going to be headed. The next page defines the sequence as a function. And this is pretty standard in math. We like to create functions out of ideas so that we can analyze them. And a sequence can be regarded as a function. Remember they showed you those charts, and there's like the first row and the second row? So the first row is like your x, and the second row is like your y. And what you have is just an xy coordinate. You could jot that down there, and you just put it on a graph, and then you can analyze them. Okay. Now we ought to be careful So domain restriction. You guys remember domain? The possible inputs. Okay, so let's just put that in there. All possible inputs. And remember, when we're doing sequences and we're doing term numbers, we start at 1. Like, this is the first term, this is the second term, this is the third term, and so on. There's no half terms, and then there's no zero term, and there's no negative term. So that's why it's the natural numbers. And the natural numbers are just a type of number. We call the natural numbers capital N or script N, and they just start at 1 and go on forever. Those are just your counting numbers, the 1, 2, 3, and so on. The natural numbers are the counting numbers. And we use the naturals for the domain. And then the range is the set of terms of the sequence. So whatever the sequence is, that's your range. And some sequences are linear. Which ones do you think are linear? The arithmetic or the geometric? Good. The linear would be the arithmetic. Do you remember linear from Math 10? What was the big thing for linear? Pardon me? Straight line layout. What was the major characteristic of the line? Like, what makes other lines different? What makes this line different than this line? It's slope, right? Slope, it's like the major feature. Like, what's my major feature? What makes me special? It's probably my hair, right? I'm just kidding. It's my eyes. No, I'm just kidding. What makes a line separate from another line? It's a slope, right? Like, what makes a circle different from another circle? It's what formula? What's the formula? Pi r squared. What makes it special? The radius. Yeah. The radius is the defining feature of a circle. Well, the slope is the defining feature of a line. So, like, if you go over one term and then goes up 10, what are you doing every time? You're adding 10. Every term you add 10. So 10, 20, 30, 40, or whatever. So the slope is just your the number that you're adding to get the next one. And then for geometric, that will be nonlinear. That'll be your geometric. So these are the ones that are like smooth curves. Smooth curves. That's your geometric. Okay, and then we don't connect. We don't connect the lines because there's no half terms and stuff. So we keep them disconnected. Okay, so they call that discrete. In other words, points not connected. Okay, so now we gotta like flip back to table A and stuff. This sucks. So I'll flip back to table A. You guys can keep on this page. And so it went 3, 6, 9, 12, 15. Okay? So that was table A. So where do we put the first dot? Do we put a dot at 0? Why? Good, no zero term. So the first dot is when n is 1. And when n is 1, Tn is 3. And if you were in science class, you would circle that dot. In math, we leave the dot. So term 2 is 6. Term 3 is 9. And term 4 is 12. And term 5 is 15. And then, because it's a line, I go like this, right? No, make sure you're thinking. Do not just do what I do because I do it, right? Think. Why would I put a line like that? Because it's linear? No, it's not connected. Because why? Is there a 1.5 term that's like halfway between 3 and 6? No. The term sequence This is the sequence. It skips everything in between. There's no line that connects. Does that make sense? Okay. Let's just do one that was geometric. Let's do table C. Okay, table C went like this. It was like 1. Where's my pen? It went 1. Table C. 1, 2, 4, 8, 16, 32, 64. Just from your gut and your instinct, does this appear to be linear? It grows slowly and then it starts to grow quickly. So it can't be linear because the growth is different. Was the growth always the same for this first one? That's why it's linear. The growth is the same. The growth is different, so they call that geometric because you have to multiply it to the next term. So when you're T1, you're like 1. So I guess that's like way down in the, here I'll zoom in. I'll zoom in for you guys. T1 is like 1. It's like right down there. You can see the scale on the y-axis is going up by 8. And then 2 would be like a quarter of the way up. You can see sort of slow growth, right? And then at term 3, it's up to 4. That's halfway. And then at term 4, it's at 8. And term 5 is at 16, so it's growing now. And then term 6 is 64. That's way up here. Oh my gosh. Did I miss one? Okay, thank you. Keep me on my toes. 32 and then 64. Good. So now because it's just, I can just see this perfect line, I'll just be like, whoa, 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 whoa. I'll do that, right? No, we cannot do that. If it was a continuous function, then yeah, we would do that. But because we are restricted to the natural numbers in the domain only, we are not allowed to connect. Okay? If the domain was real numbers, then yes, you would connect all that stuff. That's like a normal function. We'll do that stuff in this course later, absolutely. And it's probably more important than the sequences and series stuff. The sequences and series, to me, it's kind of a weird unit, and it's sort of separate than the others to me. That's the way I look at it. So it's sort of like an introduction. A lot of this is applied if you ever want to do programming and computer stuff, this sequences and series stuff. Okay, so I think we're good with what the sequences and series look like, or what the sequences look like as a function. So let's go to class example 4. Then it just says circle the correct alternative. All right, so a sequence in which the next term is determined by adding a constant to the previous term is arithmetic. The sequence is a linear function. A sequence in which we multiply is geometric and it's not linear. Any questions on that? All right. Okay, so assignment 1, this is where you will get to investigate. I don't like personally to do the investigations because then it's like you watching me investigate. Like, I don't need to investigate. I know this stuff. You do need to investigate because you're just doing it for the first time. So yes, you should be doing these assignment questions. You have the solution manual, so just one comment about the solution manual. This is for backup. This is your backup. I'm not around. Your smart buddy's not around. You don't have internet access or something. You can't get online. Nobody can help you. You have this as backup. You do not put this open to the page and your homework and cop. That's not going to get you anywhere. You have to try this stuff. And you have to fail. And then you have to ask questions. And then you have to get better. And then you succeed. The only time you will have success is if you fail, okay? I started playing soccer this year for the first time in my life, other than like when I was a kid. Like I played co-ed soccer just for fun. I'm a hockey player, right? I never really played soccer. I just fell in love with it. I sucked at the beginning. Very first game, like I got slide tackled and I fell and it hurt. But, you know, I kept trying. and I got better. And at first, like, my passes would be like way off, but now I'm like making passes, and like I even scored a goal. So, right? At first you fail and then you succeed. You cannot just be magically good at everything right off the hop. That's not what life's about. Maybe in grade 6 and teachers talking about math, you're like, I get this. But in grade 11, it's kind of not like that. So you got to put the work in, you got to put the time in, and that's enough of that. So do the work, stay quiet. If you got questions, I'm here to help, okay? I'll just write down the numbers that you're supposed to do for the homework. Okay, so it looks like you can omit. Sorry, you can omit. So that's nice. You don't have to do it all. Omit 8, 13, 14, and 15, and you don't have to do the group activity if you don't want to. Okay, so you can omit all that. So you don't have to do everything. Some people, though, I had one student last year in Math 10, like she literally did everything because she just knew that's what she needed because she was not as quick of a learner in math. But this is what we recommend, okay? But you can do them if you want. So good luck.